So this is an introduction or showing the different changes that was made on KherveFitting 1.5 in comparison to 1.4. So 1.5, at the moment we are at 1.512, and there are several differences, but it does look the same. So I was told by users that they could not see any changes. And it's still looking the same as version 1.4, but the main thing is we are going from one single data to a multi-sample data analysis. So for example, this is a sample with maybe around 100 pages in the Excel file. And you can see it here going down, and it's quite a lot. So obviously, it's a bit tough to go from one page to the next. So if I use control down, you can see it goes from different zirconium in this case. And there is an evolution that you may see in here. If I continue, and that goes up to the end. Now I'm coming to a survey. But it's still a bit tough to go through this through this box. So there is this sample manager. And the sample manager allow you to visually see in kind of 2D each sample. So in this case, it was a sample made of aluminium, oxygen, chlorine, carbon, and zirconium, and it was spotted 23 times. And so now what you can do is you can select the column and click on the plot button, and now you can visually see the evolution in one go. Could do the same for zirconium, and you can, if you just wait, it will tell you press F2, so that will do exactly the same. So if I go in here and press F2, I'm getting the same one. If I press F3, I get this one. So F3 will just give you an offset between each peak, and if you double click, then you get more offset. If you just click once, it goes back. But if I click many times, now I get a bigger and bigger offset. If I just click once, and this is the same as pressing F3, so I get one, and if I press many, I come back. So if I press F2, now I'm coming back to the non-offset, and this is normalized to the highest peak. You can change that. You can go to normalize at a certain binding energy, and that will add a value here. And you can see this. You have to click or press on the plot itself. And now if you use the shift key, you have this red line. And if I decide to be at this binding energy, then, and you can see the binding energy being updated here. Now this is the normalization to this binding energy. If it's this one here, then you get that one. Okay, so this is what has been added here. There is many more functions. There is obviously delete. You can add more row. At the moment I've got 23. If I add more, I'm getting 10 more, and you can delete some of the row. You can copy, paste, rename, and you can sum all those data if you wish to. So for example, if I wish to sum those 10 data together, I click sum, and there should be another data being occurring in here. Just it goes always at the last one. So in this case, it may not mean anything because it was only carbon. I can simply delete it because I won't do anything with it. So that will come soon. Okay, so every time you just update the thing. Okay, so this is what has been added. I can show you a more. This was maybe the biggest type sample you can do. You don't do too many because it's still 100 on pages in Excel to deal with. But the kind of files you could just do, let's say you had 3 samples and you put them together. So that will be that kind of sample now. And in this case, it's NaCl, H2O2, and so on, and you could compare them, F2, pressing F2, checking what's the difference. And what you can do now also is you can add, for example, I could add more pages in here using 2 instances of KherveFitting. So let's put that, you can see this arrow on the left, and if you put it down now, you have more space, let's say, to add a new instance. So I'm just going to add a new window. On that window, it will be a parent of the main window. So the main window is this one. So let's do the same here. I'll open maybe something else here. Let's say I open a standard sample. And it's not really a standard anymore. It's made of many files because I've been playing with it. Oh, I did the wrong one, sorry. Let me add that back in here. I always like to do the second one having where I'm going to copy to the main one. So this was done here. The old data. Okay, so preparation is sometimes a bit difficult or a bit long, but now let's say you have this data and you can open the sample manager. So this was my sample of this one. So it's made, you can see that I've been playing with it. So made of many core levels. And this is more of my quite nicely made sample. So I can then copy. Let's say if I go into this one here, I could copy the core level. This is carbon 1s2. But if I go into 9 in here and I can paste, I should get, and it's updating right now, and you see it's carbon 1s9. And that is now this peak. Yeah. When I just press it, it doesn't show the peak fitting. But if I press this, then you can see the peak fitting that was made. So again, this was the peak fitting that was made here. And if I show you like that, you can see this. So another thing that was added is, for example, if I remove the peak fitting and I wanted to copy the peak fitting of this one into there, I would simply go right-click menu, copy peak table, and I go in here, paste peak table. And now you have all the peak table which has been added, by the way. If I show you how it looks, it's been added into the row, but no need to see all this. We can see that this was added. Okay, so there is all this these possibilities. We can also copy not just one, but let's say if I go into, so you always select one first, and then now if I select the 3 and I copy, 3 core levels have been copied. So if I go back here and I would add them somewhere, so this is survey, oxygen 1s2, so I may just add, I may just put them here and I paste that, so that will be in row 10, and it takes a bit of time, but it should update it now, and you can see what was added is a survey. It may be wrongly done here, but I think if I change the name, because that should be survey 10, there's still some mistakes, as you can see. It's called survey 210, that's why it went wrong. So I can call that back. You can always rename in this this one here. So now this is called survey 10. It updated it, and if I go back now, you have survey 10. So it kind of is possible to add all of them together. So the next bit, and if I just go back to my main one, what has been also done is a backup system. So if I go into my main backup to show you what was done, So the backup system is in the main root of KherveFitting for you. So you will see straight the folder, but in my case, it goes into a weird location. So let's say now I have now in the preference things, I have a backup type setting. So right now, the files are saved every 30 minutes. But if you do some copy and paste, it will back up the previous data. If you delete, or it will also back up. There's also a clear backup. So right now, I've been playing with it this morning. So if I clear this this backup folder, so it's all gone. But let's say if I was to take some data from the, for example, STO, I was in here. Yeah, if I was in the STO, and this is quite a big file, as you can see, if I now, and I need to show you this, so let me just go, yeah. So because I opened, it just saved something. And then if I now delete this recently added OS 10, if I delete it, it should save the data. If I copy this one, it doesn't save. But if I now save it into here, paste it, then it's saved the new. So it's always saving the previous version, just in case you made a mistake, you deleted all the rows, and so you can always come back to it. Okay, so this backup, if I go back to preference, in the save setting, as I said, you can enable, disable, but the copy, delete, and paste will always be done. So there will always be files in there, and you can clear it as you like. They're not such a big size. Okay. So the next bit that was added was the binding energy checking. So this open a database. So it takes a bit of time, but it opened a database. So it's basically coming from the NIST, because the NIST, as you know, it has changed website, and I personally don't like it anymore. I didn't like it before, but it became quite worse, especially in the search, because you can't see all the data together. So for example, in here, if I click on titanium, I get my 754 elements for titanium with all those lines, put it together. You can just choose the one you want, 3.5. And then if you decide titanium oxide, now you get titanium oxide, but obviously you get more of those ones. Yeah, you get different type, like the bismuth titanium oxide. And sometimes, especially on NIST, you couldn't. You just had to play with the formula. You didn't know what was the name. And now you can also add the dioxide, and so that should really help you to filter what you don't want to see. Okay, and if you just want to see the 4 one, and in this case there are several 4, I could maybe add dioxide, and I could add a bracket. Let's see if it works. No, because this is how, yeah, it just doesn't want it to be called that way, but I could be called that way, something like that, and now you get them all, those titanium dioxide. So then you can, because it's quite a lot to look around, you can do a plot, and the plot comes like this, and you can see that we had 50 reference around 458.5. So I think it's a more visual or nicer way to go through the database than going through the NIST, and this is all available through this button here. Okay. Then I've also added different things. For example, in here, if let's say now you want to put all those samples in function of the first one, you could go in here and propagate to the column. And then you will look at the split. You see the 1.65, the 2.89. If I do that, then now you have A plus 1.65, and you put a plus minus, which is this hashtag. So that means if I now try to move them all together, they will all come. They don't come like, they don't come in this way because they are not linked into the area. But if I was to do exactly the same in the area now, propagate to column, now it takes the value in A divided by AA, and if I now try to move, then they all move. Okay, so it's again similar to Casa. I think there is if you put a star or hashtag just like you would do in Casa, then it will know it's propagate to all column in this one, but you have also the right click menu. So next one, what I've added is I've been asked to add for Raman. So for example, if you go to background, you can go in the background here and you will have a mode for ILS Raman. And that's the same as the Tuga. So if you, let's say you would, and I'm not saying you would for this, because that's not a Raman data, but if you go in here, now you get a model type Raman, and in here you could basically fit an asymmetric least square baseline to the data. And that's usually how Raman is baseline is created. So I'm not sure if it will work here, but you have also a smoothing window where you would try maybe 4, which will kind of obviously don't work well here, but if I try with a noisy Raman, usually Ramans are quite noisy, then you would get good data, especially for the noise, because it doesn't take this data. This is the excluded zone where it will not fit the background. And so if I now try this, it may do something good, something bad. He hasn't done quite well. I wasn't expecting to do something here, but then you can export the data, and so you can play around with those data to get what you need. Okay, so this was added, a Raman background, and obviously you can import Raman text right here and even a folder, and that will create Raman data that he knows it's Raman, and he will put that in the right orientation and call that wave number. And also what was changed is the different fitting models now has been arranged, and I've added the Gaussian convoluted Doniac Sunjic model. So I will show you how it works. If I now go into the data folder, again my standard, which is no more standard, it's made of so many pages. But let's say I come to strontium. This is my strontium, and let's say I would fit a background to that. And going back to the background, I would like to show. So if I use Control down to go in there, and if I'm not happy with my offset, I would then use the Shift key right now, and I can just offset this. Sometimes the V lines start coming even with the Shift key. So then you have to unpress the Shift key and repress the Shift key, and that should work. So now I can just change that. Let's say I want it to be around there, somewhere around there, and maybe somewhere around here. Okay, I can zoom out, and now I can add my Doniac Sunjic, and I will explain how it works. Oh, yeah. So my Doniac Sunjic at first it comes very Lorentzian, but then if I now fit it, and this is with an asymmetry of 0, if I fit it, then this asymmetry, unfortunately, the minimum asymmetry is 0.01. So it will slightly be asymmetric, but it's as symmetrical as it can. And so right now we have a width of Gaussian of 0.8, because that's the convoluted Gaussian, and a width of Lorentzian of 0.14. And together the convolution gives 0.96. So if I now click on tab, you can see this value being written 0.96. So that's actually measured in here. Okay, so this is an indication coming from the real width of Gaussian and the real width of Lorentzian. So that way now, if I want to fit asymmetrical peak, I will get the standard kind of Doniac Sunjic. Sometimes the V-line don't work, so you have to click on using the tab, and you can see now it didn't get the right one, so I've cleared all. And what I will do usually and you can see now, I'm clicking on Shift, and this V-line came. So if I unpress the Shift, repress the Shift, I can just play with this. And now this is kind of the backgrounds you would like for a Doniac Sunjic. And if I add this, I'm just checking if it's the Doniac Sunjic, yes. And if I fit this, it's trying to apply an asymmetry into the data. So now this is how it works. I think I've shown more or less everything. There is some beta versions of the Doniac Sunjic, but that doesn't work as well. I can show you a comparison with the standard Lorentzian, asymmetric Lorentzian. I will use the standard one here, which actually is a LA, but which is not put symmetrical. So it's straight, you can play with the sigma and gamma, and if you fit that, it will actually fit extremely well. So the LA always work very well. So this is all more or less the changes that was made in 1.5. So it's now going into multi-file with the proper Gaussian Doniac Sunjic. I think I've cleared all the bugs, but there may be more that I see coming. Okay, thank you.